Okay, so the first thing we need to check is that all the services should be running. So every time you start your machine, first thing you should check all your services are running. If you have a dynamic IP, for example, I'm getting the constantly same IP from last 3 days. Okay, why? Because it is a net. That's the reason. Okay, so I'm getting the same IP. So if you are getting different IP, then you'll have to update your which file, etc hostess, right? If you are getting different IP, okay, so etc hostess you have to update. Otherwise, your name node will not work, your Hbase master will not work, your job tracker will not work. Why they will not work? Because they start with some host. Okay, with respect to some host, they refer core site.xml, they refer mapred site.xml. So core site.xml, we have written the host name as master there, and once they try to ping master, there is no basically response they get back. Okay, so they don't start. Data node and task tracker, they will start. They don't require a particular host to be associated with them. But when they are trying to connect to name node, they are not able to connect because name node is not started yet. Okay, so let's just check whether all the services are up and running. So here name node, it's there. Secondary name node, it's there. Data node, it is there. Job tracker is there, and task tracker is also there. Zookeeper, quorum peer main is there, H master is there, H region server is there. So hopefully everything is working, like it seems that everything working fine. So now let me get into the Hbase shell, and inside that we will start creating certain so let us open up here the name nodes page. Then we need Hbase page. Okay, so we are into Hbase shell, and this is the document which you need to follow. So Hbase space shell, if you type, we get into the Hbase shell, and then if you simply type status, it will show you the status of the server. Okay, so status, and one server is present because we have only one machine, and one server means this is your region server, remember. Okay, so when we query for Hadoop as well, we do query, we want a report, so sdfs dfs admin -report, we write, so we get a report. So there we get nodes, and nodes are data nodes. Okay, so don't consider your name node to be a node. Name node is not a node. Okay, so how many data node services are running? They are nodes. Similar way here, H master is not a node, H region servers are node. Are you getting right? So in our case, we have put all of them in one machine, so that might be confusing to understand. But H master is on a separate machine in real time, and you have multiple H region servers. So if 3 H region servers are running, and that is H master, so you will get 3 as active node. Okay, because 3 are running. Okay, and 3.000 average load, that means we have 3 regions. Okay, tables is also right answer as at this point of time. Okay, but your one table can have more than one region. Okay, so if one table is having more than one region, then this will increase. Okay, so it actually based on the number of regions are being handled by the cluster, right? Okay, now this status, if you want, you can write simple, you will get a bit in detail. You want summary, you will get this way. You want detailed, you will get a whole description of all the regions. So let us just type status and detailed. So here we will get to know all the regions. So here we have root region, we have meta region, we have table 1 region. So 3 regions are here. Okay, so we are able to see that 3 regions are there. Okay, so for those 3, it is showing us the load is 3, number of online regions 3, right? So then, yeah, if you type version, so it says that it is 0.94.15 CDS 4.7.1. so this is version. Okay, now I also would like to introduce you that this is the installation which we are doing. This is all Cloudera based, right? You have seen we had installed a Cloudera RPM initially. This is Cloudera based. I'll also tell you installation with Apache. Okay, I have told you Apache is that software foundation that is giving you free licensing. Cloudera is that company which gives support and services, complete support and services for big data platforms all across the globe. Okay, so they basically use Hadoop, and Cloudera was formed by the team who actually developed Hadoop, right? So they were working at, you know, which project was that? Nudge, day one we discussed, right? So Nudge was the project, okay, in Yahoo. Okay, so once basically this Nudge was transferred in basically 2007, 2008, it was completely transferred to Apache. So that time this team, okay, so they basically came out of Yahoo and they formed their own organization. Okay, so that was Cloudera, and second organization which came up was Hortonworks. Okay, so these two are the biggest, you can say, players or giants who are working all across the globe, and many IT companies have got tie-up association with these two for big data platforms. Okay, fine. So this is Cloudera based installation. Therefore, we are getting CDH 4.7. So CDH means Cloudera distribution of Hadoop. Okay, CDH. Okay, if Apache we are doing, we will not get this way, CDH 4.7. Okay, are you getting right? Yes. So now basically let's move ahead, and if I type who am I, so it will tell me the user. So user is root, and then basically creating table. So creating table has got you can create two ways. One, you can write create table. Okay, here if you see create table name and single quotes. So you need to remember that you have to write single quotes. Okay, whatever query you are passing in single quotes you will have to pass. So after writing single quotes, you can put comma, and then inside curly braces you can pass on some properties of that table, because if I describe a table, then I get certain properties, okay, for that particular table. So if you want to modify some property, then you can modify that by passing that inside that curly braces. So inside the curly braces you have to write the property name in caps. Okay, so for example, property name, it is written name and is equal to, then your greater than sign, and then info in single quotes. So name is equal to greater than sign. This is the syntax. Name has to be in capital. So this name basically denotes your column family name. Okay, this name is your column family name. Okay, fine. Yes. And then basically next is written versions. So yesterday also I was telling you about versions. Okay, so version is equal to 3, it is written. So if for a single row you are updating the value, so there is no as such update query. Yesterday also you saw that I had written a put query, and that put query itself has updated the record, right? But in case of RDBMS we have a separate update query. Okay, we update and set the value, so that value gets updated for that particular record. Here we don't have as such. If we run the same row command for put, and we change some value, it will get updated. Okay, so if it is getting updated, then in this case where versions is equal to 3, it will store past 3 values. Okay, so for example, first I have given name as Aarti, so Aarti will be there. Second, I have given name as Aman, so Aman will be displayed but Aarti will be preserved. Then I have given as Amar, so Amar will be there, Aman and Aarti will be preserved. Now if I give Shantanu, so the first one, Aarti, will get removed. So in total 3 versions it will save. It means that. Okay, so by default also it is 3. By default also it is 3, and you can change by mentioning this way. Or else second way is that you can simply write create in single quotes table name, comma, in single quotes column family name. No need to write those curly braces. Okay, this way also a table with a column family will get created. If you want multiple column families, then you can just add comma and column family name, comma and add column family name. Okay, so create, the first parameter will be your table name, and rest of other parameters will be your column families. Okay, so that way you can create. So yesterday we had created, let's create another table. Okay, we can create one more table. If I do list here, so T1 is visible here, and let me create a table, create, and let me name it as EMP, and then here I can write column family. In column family let me write P underscore info, So this is one column family, and let's say after that I will write let's say organizational info. Okay, so two column families I have created. Table has been created. If I do list emp and t1, I'm able to see, right? So now emp table has been created. Next is describe the table. Okay, so if I will describe, so I will get all the defaults set for this table emp, because I haven't mentioned any kind of property. So here if you see, we have description. In description, first it is written enabled. Enabled means the table is active. Okay, if it is disabled, then that means table is not active. Okay, so there is a case you can disable a table as well. So once it is active, then basically you can retrieve, you can load data in active state. Then emp is table name. Then name is equal to o-info, organizational info, that is your one column family, and another column family I had created. From where does that start? It starts from
name.
Yeah, where is that?
After replication score.
Yeah, so from here. Yes. So yes, so for one column family, these are encode on disk, that is true, bloom filter none, versions by default it is 3, in memory false, keep deleted cells false. So then data block encoding none, TTL time to live this much. Okay, so all the defaults are set, and they are set as per the column family. Okay, so for a particular column family, whatever default values are there, they are already set here. Okay, and then basically if you see, this is a bit similar to JSON. This is not exactly JSON, but a bit similar to JSON, the way the data has been organized. Fine. So now let us try putting some values in the table. So the put query basically starts with put table name, and then the first thing you need to mention is your row ID after that. Okay, row ID. After row ID, what you need to mention? Your column family and column. So column family already you have, but do you have columns? No, you don't have columns. So columns are always created at runtime. Okay, so whatever column name you will pass here, that will get created. Okay, so if you will pass the column name back and again, so like once it is created, so it will be treated as same. Okay, so now I have o info and p info. So if I want to put in the table emp, and where do I want to put? Let's say the employee ID is 100, and for 100 I want to put it under p info colon, let's say I want to put name, so p info name, and then value, and value I will write Akshay. It is entered, right? Your name is Akshay, right? Okay, so for 100 it is entered. For 100, for column family p info name, it is entered. Let's say I want to put as email. So for email, I'll put here Akshay @ let's say he works in Zensor, so zensor.co.in, whatever is the email. Okay, so your employee ID, employee tables row ID is 100. For 100, p info name and email I have put. Now for that, let me change the column family. Now I'll put o info, organizational info. Okay, so here I'll have to mention a column as well. So let's say I mention a designation. Okay, so designation I have mentioned, and let's say designation he has got is big data engineer. Okay, so this is the designation he has got, so that is entered now. Okay, so now this is how you can load the data. Okay, right. If you want to scan, then simply write scan and emp, and you will get the results. So for row 100, For organizational info designation, it is big data engineer. Then email akshay@zensor.co.in, and then the name is Akshay. Okay, so the data has been entered. Yes.
Properties which you mentioned, it will be mentioned in the meta information before property.
It will be mentioned in the
Meta table information.
yes, yeah. So whatever user table we are creating, whether it is Hbase or whether it is any other database, so properties related to that particular table are always entered into meta tables. Okay, so in case of you can even see for MySQL, we have installed MySQL, right? So whatever tables we are creating, we'll be able to see their entries in the some meta table. Okay, so like there's a table for Hive. You can simply see for Hive, you go into the metastore database in MySQL, and user tables, you just query user tables, so you will get their entries. Okay, with all the properties you will get. Okay, yes, so that is meta information of that particular table. Right. Versioning I had told you, right? So we can just do it again. Let's say if I write a put query and organizational info, if I put salary here, so yes, how much do you want? 1 lakh. 1 lakh per month. So 12 lakhs package you want, right? So this is right. So now if I update it, let's give him 14. Okay, you should be more satisfied. In hand you should get 12 because tax cut jayega usme, right? So now basically if I scan, yes, so here it is 14 LPA. Okay, and if I scan with versions, yes, I'll get the previous as well. LPA is also there. Timestamp if I see, so the timestamp says 60158 68520. So this is latest timestamp. Okay, yeah, so this is versioning. Get is another command to retrieve the data. Like we have scan, similar way we have get. So get is something like putting up the clauses. Okay, scan, you are scanning the whole of your table, but get is something like you are putting some conditions. So here if you are putting get and row key, so in our case we have only one row, so let us just put some more data, right? Let's put some more data. Let's start with name. Okay, whose name should I put? What's your name? This much? Okay, fine. So for her, this is one thing. Second is after name what we had, email we had. So okay, and then basically we have designation. Let's give BI consultant and yeah, how much do we put? Anything. No, this is not right attitude. They'll say work free for us. Okay, let's put a bit higher. Okay, fine. Yes, so now the put command, get command. Okay, so in get I want data of emp, but I just want for 100, row number 100, so I'm getting for 100 only, right? I want for 101, I'm getting only for 101. So this is something like where clause, okay, where user ID or where row key or where employee ID is 101. It is this way, right? Yes. So this is one thing. Second, if you want, you can pass the column family. Okay, this way you can pass a particular column family if you want to restrict. Okay, restrict in the sense now we are getting for both the column families. If you want to restrict more, you can write here that you just want data of your column family p info. So we are getting just p info. You just want to get info of just name. So you've got column family, column name, you've just got info of your name. Okay, so this is how constraints can be applied, not constraints, clauses can be applied. Okay, so there is no as such other query that you can put where, or you can put something on clause, or okay, so we don't have that those kind of things here. Okay, they are there in Hive. In Hive you can do those things. Okay, fine. So this is how you can do. Then count will count the number of rows. Okay, so it will count the number of rows, and cache is the amount of memory you are allocating to basically fetch the records at one time. So the more memory you will keep, it will fetch more records, and quickly you will be able to count. Okay, so it is not like it will count the whole table at once. It will count certain rows. Okay, it has counted 100, then 100, then 100. So if you increase that 5000 value, so it may be able to count 1000 at a time. So that will just help you to get the results faster. Okay, that's the only difference. So if I want to get a count and emp, so sorry, only two rows are there, 100 and 101. Fine. Then if you want to delete some row, you can delete by writing delete API. So delete table name, row ID, and then particular column family column. Okay, so here also it depends that how much information do you pass. Okay, so if you are passing delete emp 100, it will delete the row. If you are passing delete emp 100, then p info, it will delete p info, name and email both. Okay, and if you are writing p info colon name, it will delete only name. So it depends like how much are you writing. Okay, so delete, then emp is the table name, and you want to delete for 100, and you want to delete p underscore info, enter. So your name and your email has been deleted. Scan. Is it there? Is it there? Yes, it is there, right? It should have got deleted, right? Okay, so let me just write here name. It shows here success. Is it there? Now it is deleted, right? Name is deleted. Okay, so the software is misbehaving. This means it says it is deleted, but it did not remove. Okay, fine. So if you want to delete all, then you can write delete all table name and row key. It will delete the whole of the data of that entire row. That means that row is associated with multiple column families. So all column families data for that particular row ID will get deleted, right? Then you have if you want to add some column family, then you have alter method. Okay, so alter will add some column family, or if you want to remove, it will remove some column family. Okay, with the help of alter. So this command is for deleting everything: alter table name and then name column family, and method is equal to delete. So this will delete the particular column family. And here the command, same command is given. So let us delete some column family. We can delete maybe pinfo. So alter and table name, and then directly if I am using delete API, this, okay, which column family? P info. No, it doesn't work this way. It didn't work this way. So let us put it under curly braces. Okay, and there we'll have to use name, and that way method we'll have to use. So it won't work this way. We have to remove this, and here we'll have to put name of the column family, that is p info, and then you have to write method, and method is delete, right? Yes, method is delete. Enter. Yeah, so again it's giving some error. So let's see what is the error, and based upon that we will modify the query. Yeah, that's what I'm reading. So for example, change max size of this for changing max size. You can say also change column family config by set attribute. Okay, sequence number will be automatically co-processor jar file location class name. Yeah, the query which we have written is alter emp, name of the column family, method delete. So what can we do is it's method or methods. It is method only, name only. Okay, method method, and it's delete. There could be more than one alteration in one command. That is fine, but I'm giving only one at a time, right? Okay, wait. So yeah, so that's the reason. Let's do one thing first. We can disable that table first. Disable emp, and yes, after disabling, let us try that command. It's done. Okay, yeah, so because the table was live, that's why it was not deleting. Okay, why? Because this is distributed application, so there might be multiple users who are still accessing those tables and those regions. Okay, so now if I disabled it, therefore now nobody will be able to access, no live operations are happening, therefore it was not getting deleted because I was deleting the whole of the column family. Okay, so disable is a concept. Now after you have disabled, then you can enable it back again. Okay, so enable enable, so now it is enabled. Now you can scan emp and you should get only oinfo is present for both the records. Okay, right, so this is how you can disable as well. And yes, flush table I had shown you. So flush table, because the records, if I want to see for this particular table, so I may not be able to see it here, though we have been working for quite some time. So emp, this is the directory, these are, yeah, the directory info is deleted, right? Because oinfo is there, I is not there. Okay, yeah, so one file is created. By this time one file is created. Okay, and its size is 916 byte. Okay, so this is created at 9:43. Okay, 9:43, just 2 minutes back it is created, right? 2 minutes back one file is created, and that is having info for 100 and 100. This is 14, this is 12. Okay, for 100 it is having, and for 101 also it is having. So there must be some command which has been run which has flushed the table, right? Because otherwise it should not have gone in the SDFS. Okay, so there are certain commands like we have in DBMS, we commit something, right? So if we commit, then the changes are preserved. Okay, so while doing like altering or so, some command has run your flush command as well. Okay, that's why that entry is there. So now no need to flush it back again. Okay, so these are Hbase queries, how you can insert data. Now basically if you see that the challenge here is we need to, when we are inserting, we need to insert one by one record at a time. Okay, so like in RTBMS we have multi row insertion is possible, so here it is not possible. Okay, so we don't have a query for that. We can insert multiple. Okay, the only thing is we can have some Java API written for it, and that will help us to insert multiple rows. Another thing is there we have certain data migration tools. So I told you to study ETL. So some data migration tools will also help us to load the data in bulk. Okay, so directly we are querying, so that time we are not getting much flexibility to store, but Hbase main purpose is to load the data in bulk, and then basically we can utilize that data. Okay, there is one tool which is called as hcatalog. Okay, hcatalog. So that tool is basically helpful for us to query data. Okay, let's say you have data in Hbase and you want to query it using Hive. So hcatalog enables us to query your Hbase data via Hive and vice versa. Okay, so you can take this as an assignment, because already you have Hbase installed, already you have Hive installed. Take this as an assignment. You have to basically read some blog or search online and configure hcatalog. Okay, so hcatalog, and you should be able to query your data from Hive, and data should be of Hbase. Okay, so cross-platform data you should be able to fetch with the help of hcatalog. So that you can do as an assignment. Okay, so we'll conclude here for Hbase commands, queries. Okay, and we will move for the next query. It is a kind of, it is if we see that it is not encrypted, like if it would have been encrypted, then the value should have been encrypted. Yeah, we should not be able to see the value. So it is a format of Hbase the way we are able to see that data. So it is Hbase form of data. Okay.
For computation, like doing
You can say because all the properties of that data is also there in the file. Okay, all the properties as well. So apart from that data,
why they are doing
sorry,
the reason why they are doing that
the reason because every database, if you see, they have their own storage mechanism. Every database has their own. Like databases don't store data simply in the file system as it is. They don't store. They have their own structure of basically storing data. I told you, like for Oracle also, for MySQL also, physical files are created. Okay, for the rows we insert, but they have their own format because whatever operations they perform on that basis. And like efficiency is the purpose, managing out the whole data, that is another purpose, and uh, it should be compact, it should be compatible if you are migrating from one database to another database, so that file should be compatible to that. Okay, so lot of factors are there. Okay, but yes, they have organized this way only. Like Hbase, they have their own format this way, and in MongoDB, if you will see, you will find JSON format. Okay, the data you will be able to see in JSON format. So they basically followed that JSON approach. They thought, okay, so these were evolved out of experiments actually. In from 2003, 4, 5, lot of experiments were being done. Okay, and these are the result of those experiments. Hbase is a result of experiment. Cassandra, MongoDB, these are result of experiments only. And then they became popular because they were widely accepted and used, and they were working well, so they were accepted. Okay, they were accepted in industry, that's why they are going on. There are many tools which are not accepted and they are no more being utilized. Okay, they're not. Hive got popular and that was accepted and that is being utilized. Pig is being utilized. Now there is a tool called as Impala that is not so as popular as Hive. It is similar. Okay, there's a tool called as Thais. Okay, not that Google app, but there's a there's a tool called as Thais, which is again like Hive. Okay, but that is not again so popular. So those which are widely accepted and which actually gave results, they are sustained in the industry. Okay, fine.